Hello, everyone. Welcome back. And I hope everybody enjoyed that lunch, which was sponsored by SoftServe. We want to go ahead and get started. We've got 2 more sessions this afternoon before we break into the Cody Awards presentation. I'm really excited to welcome our final keynote of the conference, who made his way here to the Bay Area to join us today. He's a renowned author, writes on technology, business, and culture. You might know him from his books, The Big Switch and The Shallows. So please join me in welcoming Nick Carr.
Thank you very much, Rihanna. They didn't tell me I could have used teleprompters. Gosh. I'm going to maybe scoot out from behind there. It's a great pleasure, a great honor to be invited to share some of my thoughts with you as we move toward the conclusion of this year's All About the Cloud. It's an interesting time to talk. I was thinking yesterday that it was actually exactly 4 years ago this month, that I published a book called The Big Switch that Rihanna mentioned. And The Big Switch was about cloud computing. And on the one hand, it seems amazing to me that it was that long ago, 4 years ago. But of course, it's also a very short span of time, particularly when we're talking about the cloud. And I think when I think back to those times, I remember one of the things I struggled with, one of the little issues, was whether to use the term the cloud or cloud computing in the book. Because if you remember, just 4 years ago, it was very rare, actually, that people talked about the cloud. And the term itself wasn't very well known. I mean, there were people maybe within 50 miles of here that used it from time to time. But in the general arena of IT, it was still a very new and unproven phrase. And in fact, beyond that, the whole concept of cloud computing or utility computing was treated with an enormous amount of skepticism. When my book came out, a lot of traditional IT people, a lot of corporate IT people, at that point completely rejected the entire idea of moving your data, moving your software out of your own data center and allowing somebody else to run it and trusting it to somebody else. There were all sorts of technical issues and all sorts of other easy reasons for people to say, oh, that will never happen. So today the landscape has changed completely, I think, at least when you look at the level of people's acceptance of the fundamental idea of the cloud. And we've certainly seen a revolution not only in IT functions, but in corporations and even in the general public about the acceptance of running software, storing data outside of your own control, outside of your own hardware, and entrusting it to others. But I think in many ways, the big changes that are going to be produced by the cloud haven't happened yet. We're still in the very, very early stages of what I think is a process that's going to last many years and is going to upset many assumptions, not only within the IT function, within the software business, as we're seeing already, but within corporations in general, and indeed will branch out and influence, again, as it's already doing, society and culture, the way people communicate, the way people live on a day-to-day basis. It seems to me that in the world of technology, because things, particularly computer technology and software, things change so quickly that we tend to discount the lessons of the past. We're so busy looking at the present, looking at present opportunities, or trying to predict just the near future, that we kind of dismiss what happened before. But I think anytime you have a change as big as what cloud computing represents, a fundamental shift in how corporations, how the business world and society as a whole thinks about the way it accesses and uses a very, very important resource, the resource of computing in general, it always helps to look backwards. Because I think, in fact, we see over and over again these kind of shifts, a shift between centralization and decentralization happen in the business world and the broader world, and we can learn a lot by how those things transpire, what their ultimate effects are. So even when we're trying to understand the present day and the future with cloud computing, I'm going to suggest it helps to start by looking backwards. In fact, I'd like to start by looking way backwards, back about 150 years ago, when a guy named Henry Burden built this magnificent machine, magnificent apparatus you see up here on the screen. Henry Burden was a Scottish immigrant, came to the U.S., to upstate New York in the 1800s, and took over the management and ultimately the ownership of a big ironworking plant in Troy, New York, an industrial center at the time. And Henry Burden understood what I think all corporate owners and corporate managers, certainly factory managers, understood at the time, which was if you were going to be in business, any kind of business, you also had to be in the business of producing energy. There was no way to get energy in from any central kind of source, so everybody in business had to figure out a way to generate the energy required to run all their machinery. Henry Burden, I think, understood something a little better than his competitors, which was that if he could be an innovator in energy generation at his own factory, if he could do it for cheaper and more flexibly and more reliably than his competitors, he could get a big competitive advantage. So he went out and built what was at the time the largest and most powerful water wheel ever built in the world. And you can just barely see, if you look down at the left side, bottom left side of the picture of the wheel, you can just see a guy in a white shirt standing there, and that gives you a sense of the scale of this thing. And lo and behold, Henry Burden was right. By building this, he did give himself and his company, the Burden Iron Works, a big competitive advantage. His company became one of the major suppliers of iron goods in the Northeast and throughout the Midwest for a long, long time. But I think what's particularly interesting about this story and where it holds real relevance to what we're seeing with computing and software today is what you would have found if you went back to this same scene just 50 years later, 60 years later. And what you would have found is that this water wheel, really one of the triumphs of industrial engineering of that century, had been allowed to collapse. There it is, rusting away and overgrown with birch trees and weeds and whatever. And you have to ask yourself, what happened? Why would this extraordinary mechanism be abandoned? And the first thought you might have is, well, the Burden Iron Works went out of business and the wheel went with it. But in fact, that's not true. The Burden Iron Works, even though Henry Burden himself was long gone, was still a very successful company. What happened is that the fundamental thinking about energy production, particularly electricity production, had changed thanks to technological advances in energy generation as well as in the transmission of power. Changes that are symbolized by George Westinghouse's massive AC generators. Suddenly, the assumption of all people in business that we had to produce our own energy if we were going to be in business, that we had to invest capital in the equipment, we had to maintain big staffs to keep the equipment running, suddenly that was thrown out the window. There was a network that allowed you to plug in, literally plug in, to a grid that produced all the power you needed for much cheaper and with much greater flexibility and ultimately even more reliability than you could produce yourself. And this set off an enormous revolution in business, not only in the energy production end of it, but throughout the way companies thought about operating, how they connected with customers and so forth. And if you put yourself in the shoes of those factory owners back then, this must have seemed like an incredible leap of faith, taking the most important technology, the most important resource at the time for business, which was power, and giving it to somebody else and letting them produce it for you. And if you think about it, in around 1900, it wasn't just a matter of shutting down a water wheel or a steam engine. Electricity had entered the realm of business, and lots of companies, following the historical pattern, had built their own generators and built enormously complex mechanisms to deliver their self-generated electricity to all their machinery. And this is, for instance, an English plant around 1900, a plant that made maritime goods. And if you look, you can see all these pulleys and various other kinds of rigging, all developed to get energy to different machines. It was kind of the SAP installation of its day. And I don't mean that as a joke. I mean companies had to go out and spend a lot of money for the hardware. They had to have constant ongoing maintenance, very expensive upgrades. They had to have a big staff. But very, very quickly, this very well-established model was thrown out in favor of the centralized production, the utility production of energy that was delivered over a network, ultimately a worldwide network, the electric grid. If you look between, say, 1910 and 1930, just a span of 20 years, you can see the evidence of this radical shift. Back in 1910, only about 40% of electricity was coming from utility plants, from central operations, and all of that was coming from very small-scale direct current plants, kind that Thomas Edison pioneered. And they were used mainly for lighting lights in hotels and other kind of urban uses of power. 60% of the electricity was coming from these proprietary in-house generating operations, and pretty much all factory power was coming from those. 30 years later, 20 years later, it's all changed. By 1930, you have 80% of energy being produced centrally, now by big AC generating stations and delivered over the network, only about 20% coming from those proprietary in-house plants. And that continues to evolve to the point where it's about 95% centrally produced, utility supplied, and only about 5% coming from proprietary plants, and that's basically the proportion we have today as well. So we get this radical shift in the way companies gain access to what at the time was their most important resource. An enormous leap of faith that must have seemed daunting in the early years of this shift, but gained momentum as the new model proved itself, and pretty soon, unlike Henry Burden, who thought he could get a great competitive advantage by doing it himself, it suddenly became clear that doing it yourself put you at a disadvantage to all the companies who were getting power more cheaply and more flexibly from the utility system. Essentially, I would argue that cloud computing represents the same kind of transformation of what is today arguably the most important resource in business, information. In data processing. We're going from a world in which the assumption was you built up your own data centers, you ran your own applications, often you invested in coding your own applications, you had a big staff that maintains and updates these applications. We're moving from that world to much more of a utility model for information technology in general, and certainly for software in particular. And that's not to say that electricity and information technology are similar as technologies. They're obviously very, very different. But where they are similar is that they're both what economists call general purpose technologies, which means that you don't just use them like a hammer for one particular thing. Both of them serve as a platform on which you build all sorts of appliances, all sorts of application, you have all sorts of creativity. So there's no end to the uses of either electricity or computing. And so if you're able to centralize the basic elements of those types of technologies, you can gain enormous scale economies, enormous advantages in terms of flexibility, in terms of provisioning cost. And that's really the fundamental economic driver that pushes these types of resources from a highly decentralized proprietary model to a centralized shared model, as we're seeing today. And indeed, if you look at the history of IT in business, I think you see that it is following very much what we saw with electricity or energy in general 100 years ago. We're going from the world that's really defined business since the first punch card tabulators entered the scene in the early years of the last century, and that is very much kind of symbolized by the client-server model of computing, where companies built these incredibly complex, incredibly expensive, and incredibly inefficient in-house data processing centers to run all sorts of applications as the cost of computing went down and the applications that you could run economically proliferated. And suddenly you have huge amounts of money, huge amounts of labor costs, huge amounts of capital being sunk into running your own operation, removing from that world to much more of a utility model for the supply of information technology computing in all its aspects. A world symbolized by massive data centers, just as the old electric grid was symbolized by these massive AC generators. This happens to be one of Google's server farms up beside the Columbia River in Oregon. And I don't choose this because I have any particular favoritism toward Google, but I think it's a nice image to explain where the term cloud computing comes from. It's all the steam rising off the cooling towers up on the top of this warehouse of computing capacity. If you look at basic attitudes toward the cloud, you see very much this shift that I talked about, this sense that at the very minimum, cloud computing, software as a service, infrastructure as a service, all of these things offer an important alternative to traditional in-house proprietary computing for more and more corporations. And so this was a study done last year of American companies, and the researchers went out and asked about companies' use, these are generally larger companies' use of cloud computing. And as you see, only about 3% are rejecting the idea outright. There's another substantial chunk, about 23%, who haven't even looked into it yet. But only 3% say, no, we'll never move into the cloud. And this is radically different, as I said, from what you would have seen 4 years ago if you'd done this study. Almost 40% are already using the cloud in some form, probably mainly software as a service form, and 35%, more than a third, are actively investigating it with the potential of near-term implementation. So we've had this basic shift in attitudes, but I think we're still a long way from the full adoption and the full rollout and the full consequences of cloud computing. And even today, I think you have to ask, even if the alternative of the cloud is pretty well established, you still have to ask, how far is this model going to go? How much of traditional computing is it going to displace? And where, if anywhere, are the limits to it? And certainly there are still a lot of skepticism around this question, or at least a lot of feeling that, yeah, we'll adopt a few software as a service applications, we'll do a little bit of our computing in the cloud, but most things will continue to be proprietary and in-house and controlled and run by us. But I think that is fundamentally a misapprehension. I don't think this is a fast shift, but I think it's going to be a very basic, very far-reaching shift that really changes at a fundamental level all of companies' assumptions and practices when it comes to IT. And of course, the allure of centralized utility computing has been around for a long time. Back to the 60s, when there were books written with titles like The Coming of the Computer Utility, and thanks to mainframe time sharing, everybody kind of thought that we'd move to a centralized model really quickly, but of course we didn't. So what's changed now? I think in very simple terms, what we've seen can be explained by two laws in quotes, of course. One, Moore's law, famous law everybody knows about. The power of computing at a particular price will basically double every year or two, every 18 months. And Moore's law has been continuing since it was first enunciated back in the 60s. And I think that explosion in computer power, in the attendant reduction in the price of that power, explains why so many applications, so many use of computers have sprung up over the last few decades. Whenever you take a general purpose technology and you reduce its cost, you find new purposes to which to put that technology. It becomes economical to do new things. But then the second law, named after another Intel guy, Andy Grove, much less well known, in the 90s, Andy Grove observed that the capacity of a data communications network only doubles about every century. And he meant it as a dig at telephone companies because he thought they were dragging their feet in expanding and modernizing their networks. But nevertheless, I think it gets across the fundamental reality of IT until recently. And that was, if you wanted to tap in to all the latest and greatest capabilities of computers made possible by Moore's Law, you had no choice but to build it and run it and maintain it yourself. Because the grid, the network, simply didn't have enough capacity to allow you to run applications and store data centrally. In the last few years, last 10 years, 15 years, in effect, Grove's Law has been repealed. Thanks to the build-out of the fiber optic internet, other advances in networking, suddenly the usable capacity of the computing grid has, in essence, caught up with the usable capacity of the computer itself. And when that happens, everything changes about this resource. Suddenly, companies are confronted with the fact that you can do, often more cheaply, more flexibly, and more quickly, things that you had to build and maintain yourself. You can do those things now by tapping into this incredibly powerful network with increasingly a grid of computing capacity, sophisticated software applications, enormous data storage capacity, all waiting outside for you to tap into it. If that's kind of the basic shift that explains why this is happening now, I think the best way to understand how this shift is playing out is by thinking of it in terms of the disruptive technology or disruptive innovation framework that was first enunciated, laid out by the Harvard Business School professor Clayton Christensen. And if you've read his book, as I'm sure a number of you have, The Innovators Dilemma, you're familiar with this, but I think it really makes sense. And I also think it's a powerful way to explain, for instance, to potential clients about what's going on and about the risks of being complacent about making this shift. What Christensen realized through his research is that over and over again, when we see a disruptive moment of innovation, when a new and originally untested technology displaces one that's well established, it seems to follow the same pattern over and over again. What happens essentially is that you have the established or traditional technology, what Christensen terms the sustaining technology. And as you go up on this chart, by the way, the capabilities of the technology increase. You have this technology and everybody's using it and people are more or less happy and it's fulfilling the needs of even pretty sophisticated users, and its features and its capabilities are growing fairly steadily, and people are pretty content both on the supply side and on the buyer side. And then you have this new technology come along, the green line, and it starts off at a very low level of performance. And therefore, everybody up on the red line, all the suppliers and buyers, look down at this new technology and they dismiss it. They say, oh, that's for individuals or maybe mom and pop businesses or stuff, but no way is it sophisticated and powerful enough for our complex business to use it. And in fact, the only advantage of the disruptive technology at that point tends to be that it's cheaper than the other one. And therefore, the only people who adopt it are people who are completely driven by cost considerations. They can't afford the traditional technology. But what happens is that disruptive technology, its performance characteristics go up very, very quickly. And in not too long of a time, it suddenly surpasses the requirements of even very sophisticated users. One of the important points that Christensen makes is that the green line, the performance of the disruptive technology, never necessarily needs to get higher than the red line. It just needs to surpass needs of sophisticated users. And again, when that happens, everything changes. Suddenly, the people who have been sitting on that red line, and again, it's suppliers and buyers, they suddenly are at a huge disadvantage. And the pioneers and the early adopters and the people who have moved to the disruptive technology suddenly get an advantage. And ultimately, the whole model of the technology shifts, and the disruptive technology becomes, in effect, the new sustaining technology. And I think this is what we've been seeing with cloud computing. And in fact, in almost every way, it matches up to this pattern that Clayton Christensen observed. And I think as you look at this process, you also learn something about the key concerns of the supplier community, the suppliers of the disruptive technology. And I think this is certainly very true in cloud computing, software as a service, and so forth. In the beginning, your focus is on overcoming the barriers to adoption, convincing potential clients that this is a viable alternative, and in fact, convincing them that it's a superior alternative in ways that matter enough for them to make what sometimes is quite a considerable shift in the way they think about the technology, the way they think about their business. But as the disruptive technology becomes more and more established, as you overcome those barriers to adoption, you have to shift from a focus on them to a focus on the brand new capabilities that this new model makes possible. So it's no longer about replacing the old, doing the old types of things with a new technology. It suddenly becomes, how do we think innovatively and creatively about how we can apply the unique powers and the unique capabilities that come from this new model? I think if you look at those two things, overcoming barriers in the beginning and then leveraging or exploiting new capabilities, you see those reflected in the way companies are adopting the cloud. And I think you can kind of express this in 5 different adoption models. And the first 3 are all about retooling the old, taking old processes, old ways of using information technology, shifting them over into the cloud, shifting them to a software as a service model. And so you have the rise of the private cloud, which is simply using the cloud as a technological model for revamping your own in-house operation. In many companies, particularly large companies, this is very attractive to them at this stage in the transformation, so very important place to focus if you're trying to supply into this new world. And this will be around for quite some time, I think. Another important model of adoption, again, focusing more on the past than the future, I think, is the cloud as a supplement to what you're already doing. This is probably the major area of the adoption of the cloud and even software as a service up till now, at least among larger companies. One of the great advantages of this model is you can do it quickly without putting a lot of capital at risk or even putting any capital at risk. You can get in and out of new capabilities very quickly. So if you want a cheap and flexible and fast way to expand some element of your IT function, your IT set, your software set, it makes a lot of sense to go with the cloud-based model rather than building it yourself, putting a lot of capital at risk. And as I say, that's the way many companies have been approaching this new model up till now. And then, of course, you have cloud as a replacement where instead of doing IT in the old way, putting a lot of your own capital at risk, you simply use the cloud to do pretty much everything you want to do. And so far, this has been limited to smaller companies, startups, entrepreneurs, to whom the cloud represents a way to get incredibly powerful and sophisticated IT, an IT base at a very low level of cost, not tying up a lot of what is usually very scarce capital. And those are all very, very important models of adoption, both on the buyer side and certainly on the supplier side. But I would argue that they're all about overcoming adoption barriers, mainly about doing things that you could already do with in-house proprietary operations and software, doing them with externally supplied, utility-supplied models. The other 2 modes of adoption are the ones that I think are just emerging. One is the cloud as a democratizer. And by that I mean whenever you have innovative leap in the way you supply computing or in the form computing takes, it always democratizes the power of the computer. And that sets off changes in innovations that are very, very hard to predict. So we saw this very clearly with the introduction of the PC. As soon as you put a computer on everyone's desk, you get an explosion in new applications, new ways to think about computers. A lot of companies, old line computing companies, were totally blindsided, didn't have the ability to imagine the future. And so we saw an influx of a lot of entrepreneurial companies, fundamental shift in the way we thought about computers, and certainly the way we use them. In a similar way, I think if the PC gave everybody access to a computer, the cloud gives everybody access to a data center. And I don't think we know yet how that's going to play out. But there's an enormous, I think, an enormous wave of innovation that's going to come in figuring out what can individuals or small groups do when they have a data center at their disposal whenever they want it. The second and ultimate, I think, model of adoption is the cloud as a business revolution. So if the first 3 models of adoption kind of all centered on the traditional IT function, these last 2 models, and particularly this very last one, goes well beyond the IT function to business as a whole. How does having this centralized resource for data processing, data storage, data sharing, how does it change all the assumptions we make about how we manage our supply chain, how we connect with customers and influence their choices, how we work with our partners, how we think about our employees and even the edges of our organization? Again, just as I think electricity forced many companies to rethink their operations, I think we're going to see the same in coming years with cloud computing. So if you think about these things from a supplier perspective, on the one hand, you have to think about this initial phase when much of your focus is on convincing customers that this is a superior way to go and alleviating their concerns and often their fears about this new model. And drawing again from that survey of large companies that was done last year, I think we get a pretty clear idea of what the barriers are today to adoption of cloud computing software models or more infrastructural models. They asked the same question, which was, what is preventing you from adopting the cloud or hindering your adoption of it? But they asked it both of the companies that had rejected the cloud outright and also of the companies that were actively considering and evaluating cloud options. What they found, if you look at the bottom, is that the major cause for rejecting the cloud outright was security concerns, security and privacy concerns. More than half the companies said that was the reason that they're not even considering the cloud. But if you look at the much larger set of companies that are considering investments in cloud computing, you see that security actually doesn't even make the list of their main obstacles to adoption. And I think that what that tells us is that alleviating security fears is basically the table stakes. And once you get past that, suddenly people take the cloud seriously and their security concerns begin to go away. They begin to trust you as a supplier. And for many companies, they begin to see that maybe the cloud option may in the end be even more secure than running our own data center, where we don't have the kind of high-level expertise you get when it comes to security that you get in cloud firms, in software as a service firms. And so what is preventing or hindering those companies that have made the leap to saying, yeah, we should definitely consider cloud options? If you look at this, what you find is that the number one concern, with about 26% of companies listing it, is reliability. All the other major obstacles are obstacles that come from the internal operations and attitudes of the buyer themselves. So only reliability, I would argue, is a supply-side issue. All the others, fear of loss of operational control, organizational resistance, lack of internal knowledge, reluctance to change, fear of the unknown. All of these are about attitudes going on within the buyer operation. And if you can solve these problems, if you can change the attitudes through demonstrable actions, demonstrable features and so forth of your product, I think that's the key to ultimately turning those would-be buyers into actual buyers. When we look ahead, though, to what I think is going to be the future of the cloud, I think the picture changes dramatically. And it's no longer about obstacles, it's about opportunities. And here, again, I think we can learn a great deal from looking back at the analogy I began with, which is the building of the electric grid. In the 1910s and 1920s, 1930s, all the focus was on the infrastructure itself. Massive undertaking to build out a system where you could both generate electricity and deliver it reliably to pretty much every building in the entire country, pretty much eventually every building in the entire world. But when this grid, this network became really interesting was when the infrastructure effectively disappeared as a concern, when people began to take it for granted. Then what we saw was an explosion of innovation on top of the infrastructure. And this changed almost every aspect of business, as well as a whole lot of aspects about society. So you get a complete revolution in manufacturing, for instance, as soon as you introduce the electrified assembly line. You get things like cars that used to be really expensive suddenly made for really, really cheap, and so they suddenly become mass products. You get the introduction of the Industrial Revolution into the home itself with an explosion of appliances. So suddenly people are going out and buying electric refrigerators, electric washers, vacuum cleaners, all sorts of products that are absolutely dependent upon the electrical grid and the ability to plug in. You get revolutions in media, revolutions in entertainment, all because, in effect, the infrastructure has disappeared and suddenly people are interested in what can we do that's new and that was never possible before. I think we're just at the beginning of that stage with the cloud, where the focus is going to shift from concerns about the infrastructure, obstacles to adoption, to we have this now. Now, what can we do with it that's new, that's exciting, that maybe solves problems we didn't even know were problems that we had before? And just as in the electric grid, what we'll see is an explosion of appliances, both physical appliances, and we're seeing this already with iPads and smartphones and e-readers and so forth, but also an explosion of virtual appliances, the apps that run on this. And of course, if you're in the software business, the great thing about the computing grid, the cloud, compared to the electric grid, is that with the electric grid, you couldn't run the appliances centrally. You couldn't, for General Electric to build a big utility, it couldn't run a vacuum cleaner in the utility and do much good for its customers. So all the appliances were separate from the grid supplier and had to be bought and run in the local home or in the local office, the local building. With cloud computing, it's very, very different. The fundamental appliances, which are all software apps, can also be run in a utility manner, supplied centrally. So much of this explosion in innovation is going to lodge very much with the software industry. As you figure out new things to do with the cloud, new ways to deliver those services, that data, and so forth, through a profusion of physical devices that are hooked up to the cloud. All of this next wave of innovation requires a focus not on the technology, but on the user of the technology. And again, this was true with the electric grid. It's very much true with the cloud, I think. If you examine the places where the most interesting things are being done with the cloud in business, I think they all come out of thinking about new things that the user, the people in the business, can do when they are given access to this new model of computing. And the first is, of course, simply IT as a shared utility rather than as something you do proprietarily. And where that gets interesting is thinking about not just how you can replicate the old functions and features of existing enterprise applications and business applications, but run those in the cloud. It comes from thinking about what new things become possible when we have this shared infrastructure, shared data, shared information, shared applications. If the reason we have businesses in general in the first place is that we know that people, if we bring them together and allow them to share their expertise, share their work, that we can get more value out of them than if they worked separately, then you can see that moving from an era of isolation in IT and in software to one of sharing holds all sorts of opportunities to make business not only more efficient, but more creative, more innovative, and so forth. The second I think the second key place where we're going to see a lot of innovation is what I talked about earlier, which is the democratization of IT. How do we allow individuals to tap in to what is, in essence, a personal data center? And this is all about, I think, creating new interfaces for cloud computing that make the underlying infrastructure disappear and simply allow individuals to get incredibly easy, simple access to it. One good example is Eli Lilly, the pharmaceutical company. Its scientists obviously do extremely computer-intensive research into new compounds. And up until recently, whenever there was an upsurge in this research, Eli Lilly used to have to go out and buy lots of new servers. It has 2 data centers dedicated to this research. But of course, the research by its nature is very bursty. You go out, you use a whole bunch of servers, hundreds of servers for a few days, and then you're done. So it was in this constant overcapacity situation with its own IT investments, which we see in companies all over the place. Well, with the cloud, suddenly it now just gives its scientists, corporate credit cards and tells them, rent as many servers as you want from Amazon Web Services and do whatever you want with them. And what it's done is it's created a dozen or so templates, software templates, for common kinds of research and how you can automate the use of cloud servers in doing that. And I think that tells us that if you can create those templates, those interfaces for doing all the sorts of things, both things that we've done in the past and things that we haven't done before, if you can create those templates and make it easy for individuals to tap into that power, you'll see a release of many more applications for cloud computing than we've seen up until today. The third major area, I think, of innovation comes from the appification of business. Certainly, we've seen with mobile devices the portability of computing in things like the App Store, Apple's App Store, Android App Store, and so forth, a decomposition of software into very lightweight, very focused applications that are kind of, many are hybrid in that they run on the local device, at least in part, but almost all of the very important ones, the very powerful and useful ones, tap into cloud data, tap into the sharing capability of cloud computing. We have yet to see that same explosion that we've seen on the consumer side in the business side. And I think what we're going to see is not just applications for employees, apps for employees, but apps that provide an interface to your company, to your customers as well. I was talking recently to the CIO of a big chain of home goods stores. And he was saying that, cloud computing, I can see how it's powerful for many companies, but for our company, we've spent an enormous amount of time and money creating a very complex set of connected applications that allow our customers to shop in a diversity of ways. They can go to our stores, they can go online to our website, we have catalogs, and we're not just going to throw those out, those proprietary applications we built up in that embed, in essence, our competitive advantage, we're not going to simply move to a cloud model, at least not in the near term. But where cloud becomes very interesting to us, he said, is in reaching a new generation of shoppers who are integrating their iPhones and their other smartphones, their iPads, into their shopping experience. And so he's looking at how they can craft a suite of new apps for potential or actual customers that provide value to the customers but also lead the customers to shop at his stores. And so, for instance, one thing they're working on, I don't know if they've released it yet, is a smartphone app that lets a person take a photograph of anything they want to, and back at the store, the paint shop within the store will match the color of the object that was photographed. Another application is a very simple kind of application for interior design. You design the room you want, you lay out your furniture, and so forth. And again, it connects back to the stores, to the inventory system, and creates a shopping list, puts it all together for you, and either you go in and pick it up, or you order it and have it delivered. And so I think here too, again, we're going to see an explosion of new ways to connect with customers and new ways to allow employees to work together and with their partners in other companies, all built on a slew of new and innovative apps geared toward the various devices people are using today. Another area that we're in the very, very early stages of seeing what its ultimate consequences will be is the use of social networking type of sites and applications within business. Until now, and I think this is largely largely due to those basic security fears of loss of control and so forth, there's been a hesitancy to really figure out the way that social networking types of capabilities can be used in a business context. So social networking, obviously massively important, hugely profitable in some areas in the consumer world, but still at the very early stage in its adoption in business. And I think here too, we're going to see an enormous amount of innovation. There's a casino in Las Vegas. This is a very simple example, but I think it kind of gets across some of the ways that these capabilities are going to be important. A casino in Las Vegas, a lot of its marketing and a lot of its customer outreach is very much focused on high rollers, people who create a huge amount of money for casinos. And it frequently arranges big events, builds them around the high roller community, inviting them in. And up until now, it's been very cumbersome to do that because they have to, on the one hand, reach out to the customers. On the other hand, they have to communicate in real time with lots of other suppliers and lots of partners. And the cumbersomeness of having separate systems, communication systems in their own company, in the partner's company, and then also incorporating outsiders, the customers, into those systems, always made it very cumbersome and reduced the effectiveness of that marketing channel. What they've done is they've moved it all onto a social networking platform. Suddenly, things that used to be hard, cumbersome, expensive, that all disappears. And even better yet, because the customers are often already used to this kind of way of communicating, whether it's through Facebook or whatever, it's very easy for them to adapt to embrace this new mode of communication. The final one, in the final kind of future application or future opportunity, is one that's dear to my heart. My last book was called The Shallows, and it was about some of the negative consequences of having constant access to, or even now not just access to, but constant bombardment of information, of data. And I think what we've learned about human beings and the human brain is that we love information, and we're compulsive about seeking out as much as possible, but our brains aren't very good at handling a constant influx of data, of information, and all the distractions and interruptions and multitasking that it requires, you lose something important often. And what you lose is the types of creativity and innovativeness that come when you screen out distractions and interruptions and really focus very, very hard on one problem. And I think up until now, software makers have done a very good job of inundating us with information, of opening up new ways to get messages and alerts and find information very quickly. And all of that's very, very important, as we've seen. But what software makers haven't been very good at is reducing the flow of information, screening out extraneous information, creating quieter, calmer spaces when people who are doing jobs that really require concentration and attentiveness when they need those spaces. And if we're really going to make the most of this new technology, we have to be, I think, much more sophisticated in gearing software and the flow of information to the needs of that particular person, whether it's an employee or an individual at home or a student, their needs and their way of working at that particular moment. And this is something that's very, very difficult to do, I think. I think it's easier to open the floodgates, and it's often been more lucrative up until now to open the floodgates than to close them. But it seems to me that this will be one of the most interesting areas, at least, in the future of apps and interfaces, particularly when increasingly we not only go out into the cloud for services and data, but we're kind of wrapped in the cloud all day long and constantly interacting with it. How do we recognize that this is not always a good thing and not always the best way to work? All of these, I think, are the theme that ties all of these together, I think, is the theme of building bridges. Often, when we think about disruptive innovation, we tend to think that the company that instigates the disruption is the one that's going to be most successful. So you want to be disruptive. Actually, that's not really true. Once in a while, you'll get a company that does the disruption and actually creates a massive business around creating the disruption. That's a great thing if you can do it. But most of the successful companies at a time of disruptive change are the ones who actually mend the disruption rather than instigate it. And by mend it, I mean they're the ones who figure out ways to bring customers from the old world and the old technology and the old way of doing things to the new way. So they're not just the companies that look out into the future, they're the companies who have a very strong sense of the present and where customers and clients and people are right now and what obstacles they face in trying to make this transition. So whether you're trying to get a corporate customer to switch from a proprietary mode of some enterprise software application to a cloud mode, and you're overcoming some of those internal hesitancies, or you're trying to create new things that we've never seen before, it's all about, I think, building bridges from the old world that we're leaving to the new one that we're entering. And the companies that are best at doing that, and they're not always the companies that are at the cutting edge or looking the furthest forward, but the companies that are best at doing that are usually the ones that end up with the most exciting and the largest and the most profitable business. So, thank you very much for your attention. Thank you. We have a few minutes left if anybody has questions or comments, or I think there are microphones. Or oh, there it is.
Hello. That was a great talk. Insightful, thought-provoking. I want to ask you about market structure and your reflections on that. If you go back to the electric utility model, it evolved into a series of interconnected regional monopolies with a pretty clear interface between the network infrastructure and the more competitive appliance level. If you take that analogy to the software industry, how does it play out? Where's the network infrastructure? Is there a clean line between a area that you think might be more monopoly focused and an area that might be more competitive?
Yeah.
And how would we know to predict that kind of thing going into the future?
I don't think there's going to be a clear line between those two things, but I do think there is a line. One aspect of the electric utility story that I didn't mention is that the crucial event in that whole story was when electric utilities from around the country actually got together with appliance makers and standardized everything. Standardized the current, standardized the plug size, all of that stuff, which not all of them wanted to do because there's reasons if you're in business to keep things proprietary. But it was only when they did that that suddenly you did get this explosion of innovation. Whether we'll see something similar happen in software, or computing in general, there's always this tension between wanting to lock customers in with proprietary kinds of things and the desire to standardize everything. My own view is that at the infrastructural level, we're going to see consolidation in a few massive kind of compute grids and storage grids. And then there'll probably be specialized players, but I think we're going to see a massive centralization of that aspect of cloud computing. And then the question becomes, do those companies who control the grid, in essence, also control the applications? And my sense is that that they probably won't, but it's certainly possible. And I think you're going to have, I think the ideal would be that not happen, that you want as much competitiveness and innovation at the application side, at the appliance side, even if it's necessary to centralize the basic infrastructure. We don't know ultimately what's going to happen with regulation. If the kind of infrastructure giants try to also control the application side, I think that's going to draw the interest of the government and of regulators. So there's no reason that everything. The ideal, I think, would, as I said, to have a proliferation of suppliers and competition on the application side, and to probably centralize where you need to centralize, which is the big capital investments required to run these things. But it's almost impossible to know whether we'll be able to maintain that line or not. One of the big differences, of course, is there aren't these, unlike electric utilities, there aren't these kind of natural regional players. You can kind of centralize at a higher level than that. Yeah. All the way. Work out.
So in the Valley today, there's a lot of discussion around hybrid strategies and enterprises who have data centers in-house and are also bridging to the cloud. We all know the Toyota Prius hybrid car, which is very successful. I recently saw a photo of a hybrid sailboat steamship. And I just wonder if the guys who are really great at making those really lasted very long. So for vendors who are helping enterprises make this bridge, I'm curious if you have any more insights about those who are helping facilitate or managing these hybrid environments, as opposed to just cutting to where the steam engine replaced the sailboat, for example. Tesla, for example, versus Toyota with the hybrid, just cutting all to electric. Do you have any more insight or recommendations?
I think hybrid models, particularly for large companies, are going to be around for 10, 20 years at least. So I think, the idea that a big company is going to move everything to the cloud imminently is just wrong. It's not going to happen for all sorts of reasons, good reasons and not so good reasons. And I think you're absolutely right that these bridging strategies that I talk about are often hybrid strategies. So you get Toyota with the Prius, while Toyota is making this hybrid, GM is putting huge amounts of money into purely hydrogen-based cars. They get essentially nothing out of it in the marketplace, whereas the hybrid, which gives you some of the benefits in terms of fuel economy, wins. And this is no longer, well, this is kind of a good example, actually, about how these things shift all the time, is Netflix. Back, around the year 2000, here in the Valley, certainly, there was enormous amounts of money going into streaming video, and people thought, oh, this is going to, take over television and stuff. Everybody still had dial-up connections, and streaming video was terrible. And so you get a company like Netflix saying, no, we're going to use the web for what it's good for, which is data management. You order things, you investigate movies, but then we're going to use, a very old technology, the post office, to deliver the actual video, and that's the model that won, and for a long time. Now, of course, as things move, take their next kind of natural step to more and more of a streaming model, because now most people have broadband connections, suddenly Netflix is struggling with that. So I think it shows that hybrid strategies can be extremely powerful ones for quite a long time, but at some point when you move entirely to the new model, the hybrid supplier has to be very nimble in making that transition as well. One more, maybe? No? Well, down to 17 seconds, so that seems fine. Thanks a lot. Appreciate it.